Hello, class. This is Mr. Webb, and I'm here. We're going to do some balancing equations. I know I'm out, so this is to help you out with the balancing of the equations. So if you take a look, we're going to do one practice equation. We're going to go through the steps, so you should figure out how to do this, and then we can carry on from there. Please make sure you rewind this as often as possible so that you can see the process over and over as many times as needed. Okay, so here we go. We have calcium phosphate plus sulfuric acid goes to calcium sulfate plus phosphoric acid. So we have already done the first step, which is just to simply count. Make sure that when you have a situation where you have parentheses, you distribute through. So that's 4 times 2, which is 8 for oxygen. And when we're counting, we can't forget this oxygen over here, which is an additional 4. So 8 plus 4 is going to give you 12. So just make sure you're keeping that in mind when you are doing your initial count. Now we have to figure out what's our first step going to be. I always recommend that if you have 2 elements in 2 different locations on the same side, like this oxygen, that you always deal with that last, because that will have a tendency to fall in place on its own. For the time being, sulfur appears to be balanced on both sides, so we're going to leave that alone, which means right now we don't want to be putting any coefficients where there's anything that has the sulfur element. Okay, so the first step we did was to change the coefficient of 3 on the calcium sulfate. What that did was we now have 3 calcium, and we have to add up all of our oxygens again. So 3 times 4 is 12 for the oxygen, plus this additional 4 over here, which is 16, which is why we have that there. And it changed our sulfur, so 3 times 1 is now 3. So now our sulfurs are out of balance for the time being. So the next move we made was we went ahead and decided to, let's get the phosphorus even. So we added a 2 to the coefficient of phosphoric acid there. What that did was we now have 6 hydrogen. 2 times 3 gives us 6 hydrogen. And then we have 2 times the 1 phosphorus, which gives us 2 phosphorus. But then our oxygen count changed because we have 2 times 4, which is 8 oxygen over here. But then we have our 3 times 4, which is 12 over here. So the 12 here and the 8 over here give you a total of 20. All right. So now this is what we're looking like so far. We have the calcium is good, the phosphorus is good. Our oxygen is still off. We have a 12 to 20. Our hydrogen off. We have a 2 to 6, and our sulfur off. We have a 1 to 3. So we're going to continue going from there. The last step we did was we're going to have to put a 3 by the sulfuric acid, and that's right there. What did that do for us? So that changed our hydrogen count to 6 right there. So that actually balances us out on both sides, 6 and 6. What does it do for our sulfur? We get 3 times 1, which is 3. That now balances us off with our sulfur over there. And then we have our 3 times 4, which is 12. But we also have to add that to the oxygen over here, which is 8, 2 times 4. So we have 8 and 12, which again is 20. So now when we look back at this, take a step back, we are now balanced. And all we did was fill in a 1 on the edge all the way over there, just to make sure we fill in our coefficients. So we have a 1, 3, 3, 2 coefficient ratio there, and everything is balanced. All right, so we're doing the types of reactions. The first type of reaction is a synthesis reaction. Synthesis is when you have 2 or more reactants in one product. As you can see, A plus B equals AB. Typically, when you see the synthesis reaction, you will see multiple reactants and then one single product, which is going to be a combined compound of some sort. So that's a synthesis reaction. All right, the next type of reaction is the decomposition reaction. This is pretty much when things are breaking down. You're going to have one reactant, which is going to be a compound, and then you're going to break that down, and you're going to have multiple products. Normally, you have one reactant, or you're going to start with one thing, and then you have multiple products, or it's going to break down into several parts. So decomposition. So the next type of reaction we have is a single replacement reaction. This is where you have a single element that switches places with an element in the compound. Again, you have D plus BC goes to C plus BD, or A plus BC goes to B plus AC. Now, I know that may sound complicated, but just imagine that this is like a relationship. I like to call this the home wrecker problem. Now, the reason I call this the home wrecker problem is because the D is going to come in and take the place of the C, leaving the C out by itself. So now B and D are a nice happy couple, but C is now lonely. So I call this a home wrecker. There's going to be some criteria that you're going to need in order for this to happen. But let's look at the bottom one. A is by itself, and B and C is a couple. Now B is lonely, and A is with C. So you guys are in high school, so you guys see this kind of relationship stuff happen all the time. But just call this the home wrecker problem. Single replacement is the home wrecker problem. Okay, So the only thing about this here is the non-metal here, D, can only replace another non-metal. Just like in a relationship, typically when you have a girl and a guy, the guy can only replace another guy. Now, I know that may not be the way things go these days, but that's what it is. Okay? And when you have a metal, okay, the metal can only replace the metal, or the positively charged thing can only replace the positively charged thing. So A can only take the place of B. It cannot take the place of C because C is negatively charged. So positively charged can only take the place of the other positively charged thing. So just think about it that way. The pluses and the minuses must go together. Okay, one of the other types of reactions is called double replacement. This is when two compounds switch partners. I like to call this the do-si-do problem because when you do a do-si-do, when you do a country line dance, you kind of switch partners. So as you see here, A is with B, and then C is with D. But when you look on the product side, A is now with D, and C is with B. So it still has to be a positive-negative combination. You see A positive matches up with the D negative, but it's just going to be switch partners. Sorry about that. So the C positive is going to be with the B negative, and that's why C is with B over here. Still have to have that positive-negative relationship. The positive still has to come first, but you're pretty much just switching partners there for the double replacement. Okay, and the last type of reaction is the combustion reaction. This is a special type of reaction. The main thing you're going to watch out for is the carbon dioxide in the water in the product. Now, you see that how it has an X, CX, and HY. That's because it doesn't matter how many carbons and how many hydrogens you have there. As long as it's something called a hydrocarbon, a carbon-hydrogen combination, it doesn't matter what it is. And then it's going to be combined with oxygen gas, which is O2. And then the products are always going to be CO2 and H2O. So this is very easy to distinguish amongst your reactions. You just have to look for so many specific pieces. It has to be a hydrocarbon, an oxygen gas, and that's going to form carbon dioxide and water. Okay, I'm doing another video on how to do one of these problems here. This is a combustion problem. We can tell because we have the O2, we have our hydrocarbon, oxygen gas, and then our products are carbon dioxide and water. We're just going to go ahead and solve this. The first thing I'm going to do is go ahead and do my list and get my initial count. Okay, as we can see here on the reactant side, we have 3 carbon, we have 6 hydrogen, and we have 2 oxygen. On the product side, we have 1 carbon, we have 2 hydrogen, and we have 3 oxygen. Again, we have the 2 plus the 1 oxygen over there. All right, so what is the first move to do here? Again, I see my oxygen in 2 separate places over here, so I'm going to do that last. First thing I think we can do is match up these carbons. So we have a 3 here, so I'm going to go ahead and put a 3 right in there. And that's going to give me 3 carbon and 6, 7 oxygen. Okay. All right, then next I see my carbons are matched up now. My hydrogens are going to match up. So I have 6 over here and 2 over here. So 3 times 2 is going to give me 6. So now I have 6 hydrogen, but now my oxygen count changes. So I have 6 plus 3, which is now 9. Okay. Now I'm completely balanced on carbon and hydrogen. The only thing I would do here is what times 2 equals 9? Now we know that's a 4.5, but we can't have decimals as coefficients. So one of the tricks to do with these combustion equations or reactions is to see where you get that half coefficient and then just multiply everything by 2. So we're going to just multiply everything by 2. So we have a 1 here, multiply that by 2, multiply this 4.5 by 2, gives us 9. That gets rid of our decimal. Multiply this by 2, gives us 6. Multiply this one by 2, that gives us 6. So let's go and see and count, see what we get after we do that. Okay, so now I'm going to take my count with my new coefficients in there. 2 times 3, which is 6 carbon. Okay, 2 times 6, which is 12 hydrogen. We have 9 times 2, which is 18 oxygen. And 9 times the 2 there. Then on this side, we have 6 times 1, which is 6 carbon. We have oxygen. We have 6 times 2, which is 12, plus 6 times 1. So that's going to be a total of 18 oxygen. And then our hydrogen is 6 times 2, which is 12. All right, if we take a look at that, now we have 6, 12, 18, 6, 12, 18, and now we are finished. Again, the key to these combustion is to find out where you get that half coefficient and then just multiply all of them by 2 or whatever number you need to multiply them accordingly. So the homework for my academic class will be to do this balancing act worksheet. Don't really worry about the top paragraph too much. I just want you to focus on balancing the equations. You can also probably identify these equations at this time. I also want you to complete the types of reaction worksheet. Again, this is more practice, excuse me, balancing equations and identifying each type of equation. Remember the 5 types we talked about: synthesis, decomposition, single replacement, double replacement, and combustion.